Good morning, good afternoon, good evening, wherever in the world you are. Welcome to today's webinar, How Crusoe Built an AI Cloud Service for Scale. Today, we've brought together a team of AI infrastructure experts to share insights on ways Crusoe upleveled their compute cloud for higher performance and for greater efficiency. I'm Janet LaFleur, Director of Product Marketing at Lightbits, and I'm happy to be here today with Mike McDonald from Crusoe. Mike leads product management for Crusoe's high-performance, low-cost, carbon-reducing GPU platform. His mission is to build platforms that developers love, and today he'll be giving us an inside look at how they built their Crusoe cloud. Then we have Alexei Stolyar, Development Director from Integrated Computer Concepts. Alexei has a long track record of helping companies build cloud infrastructure, and lately that means a lot of AI and high-performance compute clouds. If you want advice on which GPUs, which servers, storage, and networking will help you achieve your goals, Alexei is your man. And then we have Abel Gordon, our newly minted CTO here at Lightbits Labs. He previously served for 7 years as our chief systems architect. Abel brings deep storage expertise from his key role in architecting the Lightbits platform, building on a strong experience in software development for cloud infrastructure and modern data centers. So we have a packed agenda for you today. We'll start with a few roundtable questions just to set the stage and to introduce you to our experts. Then we'll hand the mic over to Mike, who will introduce you to Crusoe and give us a deep dive on how they built their GPU cloud. And he also has some key benchmarking that kind of drove some of their platform design. Then Abel will give you an overview of the Lightbits storage. It's an integral part of Crusoe's platform. And then we'll go to Alexei, who will detail on how he goes about advising his clients on how to select and put it all together for maximum impact. Then we'll finish with a Q&A. So if you have a question, there's a little question mark on the sidebar. You can simply select that and then type your question in there. And we'll do our best in answering them all at the end. So let's go over to our roundtable. Let's see everybody up close and personal here. First, this one is for Mike. In what ways are enterprises, your customers, how are they looking to capitalize on AI, and what are the challenges they're facing doing that?
Yeah, that's a great question. So what we're seeing in AI is a lot of interest and a lot of trying new things and trying to figure out sort of how AI fits into your business. We're seeing a lot of really cool consumer apps, a lot of content generation, right? Everyone has used ChatGPT in some way, shape, or form, a lot of image generation, et cetera. But today, I think a lot of businesses are sort of viewing AI or integrating AI as the, add a sparkle emoji in an overflow menu, right? And integrate your AI feature. I think the trend that we're going on, though, is how is AI just fully integrated into the application development experience, right? Or the application usage experience. So not having it be a thing that you have to consciously think about to use, but just a pervasive sort of feature built in. I have a bunch of friends building an email app, for example. And it's not just, give me a summarization, it's automatically summarize everything and then start intelligently sorting them, right? So people are building better recommenders, people are building, better content classifiers, all of those things. They're just sort of trying a great number of things and finding out what's working. I think over the course of this year, we're going to see that just become a first-class experience, right? It is going to be, more of the air we breathe in that application. And obviously, we're building a cloud. We think AI is going to be ubiquitous. And so usage is just only going to go up from here.
Yeah.
It's a long-winded answer.
Yeah, well, I could really use something that would go through my email every morning and tell me what to prioritize before I even have brushed my teeth. So, great. So, Alexei, do you have anything to add from your perspective?
Yeah, I think, the enterprise world will also kind of figure out how it's useful for them, right? So there's a lot of data, how to analyze the data, and how to get useful results from it. And we do see it in different verticals and in different markets. And we'll start seeing adoption in specific markets quicker than others. But I think everyone's kind of trying to get their AI is a big buzzword right now, and there's a lot that's happening, and a lot of tools are being developed, and a lot of useful use cases are being developed. And as the next few years progress, we're going to see it more and more usefulness and more in real life type environments.
So yeah, for people looking to do this, Alexei, what are the different approaches that you see them taking, and what are the advantages and disadvantages of them?
Well, there's so much happening in AI, and you kind of have to break it down in terms of what we're looking at, right? So if we're really looking at from an infrastructure or starting to build a platform, right? You start with the application, you start with infrastructure. So really you have to break those out, right? And so if you're looking at from an infrastructure perspective, there's different ways to build it out. There's on-prem, there's in the cloud, and they all have their pros and cons. And also understanding the models, the AI models that are being run, and there's so many that are being generated right now. And data scientists are all over the place, and so really just need to pick a starting spot and start developing and brainstorming and putting the system together.
Great. Thank you. So Abel, where does storage fit into this equation?
That's a great question. So AI is all around data, right? You need to process data. You need to make decisions based on the data. And it's not just data, it's huge amount of data that you need actually to process at, I would say, very high speed. All these speed and feeds are a critical part of the data management. And also it's data that you need to share across multiple AI instances, for example. Now, if you look at the different storage options, you will see people talking about block storage, file storage, object storage. Now, all of them require an underlying block storage device. Whether you are running with a local file system, shared file system, or object storage, you need a block device. Now, generally speaking, shared file systems and object stores are great when you need to share a massive amount of data across multiple instances. And it can work perfectly, but it all depends on the, I would say, performance requirements of your AI pipeline. Sometimes, the throughput and the latency that you get is sufficient to feed all your, GPUs and do all the, for example, training or distributed training, but sometimes may not. Now, block storage with, for example, a local file system can also be an alternative. If you have an AI pipeline that requires extremely high performance, a lot of throughput, low latency, you can just build a local file system on top of a block device. And that's why we see that, for example, Crusoe, and I assume that Mike will be covering this later, you have instances that not just have GPUs, but also have local NVMe devices.
Mm-hmm.
And it's not just in Crusoe Cloud. Even if you look at the public cloud, you will see that most of the AI instances, the virtual machines or the environmental servers that you get, have GPUs and local NVMe. So block storage is, I would say, the key part of any AI solution.
Yeah, it's the basis. Okay,
Correct.
so that is the last of our roundtable questions, and I'd like to hand the mic over to Mike, who will go through how Crusoe built their cloud.
Awesome, thank you very much. And to Abel's last point, I was in a meeting the other day where someone sort of brought up the vastness of the data problem, right? So we've told enterprises over the past decade, 2 decades, to hoard all of their data. And so enterprises have tens of petabytes of data sitting somewhere that they don't really know what to do with. We've sort of tried various solutions, over time of doing the Hadoop and the Spark and, all of the ETL things. And Snowflake obviously has built a very big business on how we extract value from data. I think AI is going to really break that open of how do you actually get insight from unstructured data. We spent years trying to structure our data, and then with data warehouses, and then everyone built data lakes that turned into data swamps. Now I think the concept of an LLM or an AI model as a way of deriving business value, I think is really actually where a lot of enterprise AI usage is going to go. Maybe even less so than pushing it out into the consumer space.
Yeah, and finally pay off on collecting all that data for so long and storing it. Yeah. Okay. Great.
To Abel's point, like, you have to be able to have the compute to do that, and that's, I think, a big portion of how we've thought about building our cloud. We'll actually start briefly with a sort of who Crusoe is and what our sort of mission and vision are. Our goal is to align the future of computing with the future of the climate, right? So the future of computing is sort of on this increasing arc. I'm sure everyone has heard of Moore's law of, your compute power doubles every 18 months. We are, happily riding that exponential into the future. And that is powering a lot of innovation, right? We get more flops, and that leads to more and better technologies, and ideally sort of a better human condition. At the same time, though, powering a GPU is an incredibly energy intensive thing, right? These are, an H100 is 700 watts, and it's only going up from there. So we want to make sure that we are sort of building a cloud platform and powering that human progress in a climate aligned way. So we build digital infrastructure that leverages wasted, stranded, and clean energy sources to power that computation that is itself powering our collective progress. Our sort of flagship product is this AI and high performance cloud platform that I'll talk about over the next couple slides. And then we also do quite a bit of digital currency mining and similar. On the AI cloud platform, our vision here is really to be this sort of hybrid AI cloud platform to power human progress. We have to be the right price performance for customers, and we're going to talk a lot about performance in this webinar. We know that customers want to be at sort of the pointy end of the spear, generating new foundational models or running inference, but they have to do it in an economical way, in addition to a climate aligned way. We also are gonna talk briefly about hybrid, and I know Lightbits is actually doing a very good job of running Lightbits wherever you are, and we can talk about that, I'm sure, in a couple slides. But not only do we recognize that customers run their GPI or their GPU and AI workloads wherever they can get capacity, we need to integrate with that. I also am trying to rebrand hybrid sort of in the climate aligned, energy efficient way. But I want to be very clear, right? The hybrid cloud of the 2010s was a Prius. The hybrid cloud of the 2020s is an F1 car, right? You don't have to have the same compromises. You can get the high end of performance in that energy efficient, climate aligned way. And then lastly, I really do want to highlight we're building a platform, right? And Lightbits has built a platform that has enabled us to build our platform. And we want to continue providing functionality at every level of the stack to meet customers where they are. In terms of workloads, it's going to be pretty heavily skewed towards things that people are doing on GPUs today, primarily machine learning, training, and inference. So we have a number of customers that are training foundational models across thousands of GPUs. And then we have an equivalent number of customers that are doing generative AI workloads, image generation, text generation, et cetera, and other forms of inference. We do also have a number of customers that are running scientific computing workloads. We have a really cool customer that's doing nuclear fusion simulators. We have a customer doing climate modeling and basically trying to build a global weather model, again, to sort of help combat the effects of climate change. And there are a lot of really other interesting use cases around protein folding, computational biology, drug discovery, et cetera, that again are sort of pushing forward what we know about humanity and our condition. And then the last one, obviously, putting the G in GPU. we do obviously have GPUs that support actual graphics processing workloads.
Go figure.
As a platform, it's going to look pretty similar to a traditional infrastructure as a service set of offerings, right? Offering virtualized GPU and CPU instances, storage, the whole reason we're here today, both the sort of local NVMe on GPU instances, as well as the remote persistent block storage powered by Lightbits. And then, as Abel mentioned, people are building file and object on top of our storage optimized instances plus additional data stored in Lightbits. And I'll do a quick performance update on that. And then on the networking side, right, you have to be able to get data in. You have to have machines talk to each other. We have high performance VPC networks, so 200 gig Ethernet between machines with all of the sort of nice multi-tenant cloud features that you would expect, right? The ability to control your ingress firewall rules, the ability to create additional subnets and networks, things like DNS and load balancers just to make life easier. And then on the GPU side, adding high performance RDMA networks between our H100s and our A100s. So again, you can do very large compute clusters of hundreds or thousands of GPUs all talking to each other over that very low latency network. So let's get into the sort of, brass tacks of how we built it. Initially a sort of very early on way of building a cloud, you might think about, hey, you just stick a server in a data center. That server has GPUs, those G0 through G7 at the top of these. Those are connected to CPUs. The CPUs are connected to all of your other peripherals, your memory, the disks down at the bottom, your networking card, etc. And initially, when we built Crusoe Cloud, just sort of starting to build our control plane, starting to get customer feedback, every server was an island, right? All of the data in those dark red disks was co-resident and physically resident on the actual server. So if a server shut down, we couldn't move a VM around. That's kind of a problem, right? We need to be able to do that. Obviously we sort of, because of the data being there, we can't migrate, we can't shut people down for maintenance, etc. So we went through, how do we actually pull data off of the physical machine, serve operating system disks, serve additional data disks. And, through ICC, through talking with Lightbits, we did a ton of performance testing, right? We knew that customers needed high performance block storage to serve that base operating system and to feed all of their, ML training and inference workloads. So we did really good performance testing with Lightbits and a sort of popular open source product as well. And we basically found that Lightbits blew everything else out of the water from a performance perspective, right? We're seeing consistently higher and sort of, just generally higher throughput and IOPS, as well as consistently lower latency across the board, right? And we know that certain customers are reading large reads, certain customers are reading small reads, depending on what it is that they're doing. If they're doing a lot of text, it's a lot of small things. If they're doing a lot of video, they're trying to grab large files. So we were really, really impressed with the performance and the consistency of working with Lightbits. And that led us to be able to pull all of our sort of persistent storage out of our individual GPU machines. We could buy cheaper, faster drives and put them as the local ephemeral drives in our GPU servers and have our Lightbits cluster serving the operating system disks. So, when you create a VM, you can select an Ubuntu 2204 image. That's all backed by the Lightbits cluster and served remotely into our data centers. And then data disks, if you want to add additional storage, right, you have trying to get access to that 20 petabytes of enterprise data that you have. You can create multi-terabyte disks, attach them to your VMs, and have that be served extremely performantly from Lightbits. We've also actually fairly recently started doing additional performance optimizations, right? We weren't happy, because we can always do better especially in sort of performance and latency sensitive AI workloads, we've actually been working to re-platform our virtual machines on a tool called Cloud Hypervisor, and we're seeing phenomenal numbers coming out of Lightbits, serving those, sort of, again, more like storage performance optimized workloads. On a half of one of these, storage optimized CPU instances, we're seeing 750,000 4K IOPS, which is like, we have to charge more, right? We got to charge more for IOPS now. Those are crazy numbers. And so we're really, really happy with those performance numbers. Similarly, you can see bandwidth, and we're just getting really consistent jumps as we go from, our smallest instance sort of up the chain. We're very, very happy. And actually, we're happy to the point where we are launching an L40S instance. So one of NVIDIA's newest sort of PCIe GPUs, primarily in our mind for inference, with no local NVMe. All of the storage is being served over Lightbits because we are so happy with how predictable, how performant, and how cost-effective it is to do that. So what's next, right? Lightbits has provided us this amazingly performant foundation, but it's also provided us a bunch of other functionality, right? So being able to do snapshots and build in automated backups for customers so they can sort of time machine back a VM and get it to sort of any point in the past in case they've done something. AI and ML folks, they're spending all of their time in Python environments. You're going to spend a bunch of time getting it set up, and if something gets screwed up, it would be amazing to say, hey, I want to go back to tomorrow. I don't know what I did. We're gonna just escape and get back to a safe path. We also want to let customers create their own VM images, right? We know that they're going to want to build their Python VM in, and they're extremely opinionated about Conda and all of those random other Python package managers. They want to just have that available. And again, we can build a nice layer on top of that to create and manage our underlying block devices. And then lastly, right, this is going all the way back to that sort of high performance and price performance piece on our vision side. We are working with Lightbits to continue to push the boundaries of what high performance storage means, especially as we start getting into multimodal workloads, right? When we're starting to have AI models that are doing text, image, video, all of those things, that is a very wide gamut of storage workloads, and we need to continue to optimize performance and efficiency. Awesome.
Thanks, Mike. That was really interesting. I know the whole idea of the fact that you have different types of data, like a video data is very different in its structure and being able to handle them all well. I can see that as a real value. So let's go over to Abel, and he's going to talk about the Lightbits data platform and how it's architected to be able to do everything that Mike was talking about.
Thank you, Janet. So Mike was talking a lot around performance, and he was showing you how much throughput, IOPS, low latency that you can achieve with Lightbits. And it's not just about performance, it's also about cost efficiency and resilience. And that's what we provide with Lightbits. With Lightbits, you basically get this software-defined storage that gives you high performance and resiliency in a very, I would say, in the most efficient or cost-efficient way. You can run Lightbits on a private cloud, as Crusoe are doing. You can use Lightbits as a building block for all your storage on top of this private cloud. You can run Lightbits on a public cloud as well. You will get up to tens of millions of IOPS. Mike was actually showing some figures with consistent sub-millisecond tail latency. While we still protect the data, this is very important for the resiliency part, we still protect the data doing synchronous replication across availability zones and failure domains. Now, before I jump into the details and I explain how we do all this magic, let me first cover what are the storage options available today. So you can always go with the direct attach model, and actually Mike was referring to it as the first step that Crusoe were doing in their first implementation of the cloud. The challenges with the direct attach model is basically that you are relying on the application to protect the data, to replicate the data, and you cannot actually share your resources. You may have an application that's running in a server with CPUs, SSDs, may not be fully utilizing all the CPUs, SSDs, or even GPUs, but you cannot move them to the other server because you're just running on a very specific configuration. So you end actually wasting a lot of physical resources. We also have, I would say, the traditional model where you can just deploy the SAN, storage area network, which means, okay, I get an appliance from a vendor and I put it in my data center. But then you lose all the flexibility from software defined. You cannot select the hardware that you need. You cannot adapt the hardware to the requirements of your data center. And in addition to that, these type of appliances may actually force you to do some kind of network reconfiguration and network adaptation to be able to get all the speed and feeds that you need. The other option that's very common, it's an hyperconverged infrastructure where you deploy the virtualization layer and you just pull all your resources, CPUs, storage on top of multiple servers. All these resources are shared across virtual machines. It's good for running, I would say, workloads that do not require a lot of performance. But when performance is critical, this type of platforms will show you a lot of inconsistencies with regards to latencies. And also you will see that you cannot push all the bandwidth and IOPS that you may need. In addition to that, scaling such platforms by, you just need more storage or you just need more CPUs or GPUs. It's not something easy because you just put a server that has all these resources and typically it's a kind of fixed ratio between compute and storage that you cannot dynamically adjust. Now, with Lightbits, we are providing a totally different model. It's a software-defined platform. You run the Lightbits software on servers, standard servers, equipped with NVMe devices, and we pull all these servers together as a single cluster that can provision storage for all your applications. In the case of Crusoe, we are talking about the AI virtual machines, whether we are talking about instances that are equipped with GPUs or CPU-only instances. All of them connected over standard Ethernet network to the Lightbits cluster, the purple box that you see in the right. And we can achieve this high bandwidth, low latency using the NVMe over TCP protocol. NVMe over TCP is the fastest protocol that runs on top of standard TCP/IP network that was designed from day one to give you all the bandwidth, all the IOPS with consistent low latency. Now, typically you may not need a lot of performance, but as you grow and you have more workloads and you need more capacity, more performance, you need to scale. And that's also something that Lightbits solves because you can deploy the cluster, let's say 6 servers, and start adding more servers as you grow to the same cluster, so you will get more capacity and more performance. Now, I was talking a lot about network TCP/IP, NVMe, and performance, but there are also other aspects to take care that you can get all the performance and low latency end-to-end from your application to the storage. And it's how you manage your NVMe devices, how you write and read data to the NVMe devices. And Lightbits has a software layer that sits on top of all these NVMe devices, what we call an intelligent flash management, that is responsible for putting the NVMe devices in their optimal working mode. No matter how you're accessing your data randomly, sequentially, big block sizes, large block sizes, as Mike was mentioning before, there are different workloads. Some of them may read a lot of data. Some of them may just read small portions of data. But for all of them, when they are running even together in a consolidated environment with Lightbits, you need to have the ability to organize the data in a very efficient way. And that's what we do with intelligent flash management, which also keeps your data protected from SSD failure. So high availability and resiliency are also critical. It's not just, okay, I put my data, I have all the performance that I need, but how you keep the data protected from failures? How you take care that your applications don't have any service disruption during a failure or even just during an upgrade? These are very important features that we implement via two-way and three-way replication within our Lightbits cluster. So, summarizing from the technical point of view, Lightbits gives you a software-defined storage cluster with all the resiliency, protection, and scalability that you need. We don't require any specific network configuration. We run on standard Ethernet, TCP/IP. More importantly, we don't need anything in the client side where the applications run, because we just use a standard protocol, NVMe over TCP, which, by the way, we invented, but we can talk about this in a different occasion. But we contributed it. It's part of any Linux distribution. It's also supported by hypervisors such as VMware. We were working with them as well. So you don't need to install anything in the client side. And as I mentioned before, also the way that you manage the flash, the NVMe devices, the intelligent flash management that gives you higher performance, lower latency, as well as data services. Mike was talking about snapshots, clones. All these are key capabilities to build a cloud. And these are the capabilities that you will need for the cloud customers to manage images, to manage data sets, to share all of them, to customize. Very, very important. And of course, we have additional layers of efficiency with same provisioning, compression that gives you the ability to manage, get more from your physical capacity. So finalizing, I would say if you are considering building AI clouds such as Crusoe or any other type of cloud service, I will strongly recommend that you look at Lightbits as the building block to get cost-efficient, resilient, and high-performance block storage.
Great. Well, thanks, Abel. For walking us through all that. And it's time to talk to Alexei, and he's going to talk about how he and ICC approach helping their clients just make all these decisions on how they build their cloud.
Yep. Thank you, Jen and team. So here at ICC, we offer a lot of services around deploying systems, deploying infrastructure. And so we listed a few here just to kind of how we approach. So we usually start off with an architectural design that includes, where the system's getting deployed. How does the networking look? How does the storage look? There's always a big question between cost and performance optimization, power utilization, right? So how much power the systems use. So all of that really comes into play, the developing the system and the architecture, and the testing, performance testing, all of that is built on the architectural design. Then we also do the supply chain. So just making sure that when we deliver things, that it all arrives at the same time, right? You don't want to have systems, compute systems without any storage just laying around. So it's a big expense. So really just making sure from that supply chain that things are arriving at appropriate times and can get deployed quickly. So it's a very, very important piece. And then we can also help deploy and validate the system that the performance is working correctly. How does it integrate into customers' DCIM tools and workflow optimization? So we really help with that as well. And then also from life cycle, right? What happens if something does not work? What is the process? What is the process to get an exchange? What is the process to make sure that the whatever's not working is troubleshooted correctly? So we can really help create runbook manuals and processes to support it and create life cycles for upgrades. And then a new area that we're focusing on is really model optimizations as well. So we've been having customers really reach out to us, and we're building a team to really optimize models, RAG services, to really tweak the models to get the most performance possible. So for our Lightbits based systems, what Crusoe is deploying, we really have a turnkey reference architecture. So we always start off with this base. It's a gigabyte 2U based server, really supporting up to 24 NVMe drives, and then a few additional drives for OS. And then really, it's very important to make sure that the system is balanced correctly, and that it's balanced correctly, that it's built well. And then so this is our reference architecture. We would always start off with something like this, and then really tweak it for the customers depending on, do they need more performance, do they need more resiliency? So depending on really what they're looking for. And then with Crusoe specifically, we do offer some of these services. So we offer we capture some of these things during our production, such as the PSIDs on the NVMe drives. We also provide the MAC and serial numbers. So for the MAC addresses, so they can deploy the systems in their automation tools really easily. The serial numbers just from asset tracking, and just making sure that it's really easily deployed. And then, as I mentioned, kind of the balancing of the system, so that it's properly divided into NUMA nodes, again, to make sure that the performance is there, and then to have access to all the NVMe drives and to allow for to expand the system, and as it grows. So these are just some of the key points that we work with. Again, there's a lot more to this, but these are just some of the things that we do, and to really make a successful cloud. So that's all I have. So
yeah, thanks, Alexi. Great information. So it's time for questions. We've already had quite a few come in, but it's not too late to send more. And just hit that little question mark on the sidebar and type in your answer or your question. So let's see. The first one is, this one's actually for Bill. How did you say you manage data protection? Was it replication or erasure coding?
That's a good question. So we do both. Within each server, we use an erasure coding mechanism to protect the data from SSD failures. We have what we call an elastic RAID. So if an SSD fails, we immediately change what's called the stripe width of the RAID and continue running. With a self-healing capability where we protect the data without waiting for a person actually to replace the NVMe devices. One of the important parts of a cloud is that you need to have software with self-healing capabilities. You cannot wait for a person to go to the data center and start replacing parts. That's not going to work. So you need very robust software that can deal with the failures, do all the self-healing capabilities to reprotect the data and continue running for long. So that's where we use the erasure coding within each server across NVMe devices. In addition to that, we use replication to protect the data from server failures across multiple failure domains. Specifically in the case of Crusoe, and Mike can probably extend, they have different failure domains. The data centers are well architectured, so we are aware of this topology, and we take care of keeping the data across these different failure domains. So if one goes down, you still have access to the data.
I was actually going to chime in when you were talking through the sort of functionality of Lightbits, and you brought up the resiliency and operational capabilities. Building a cloud is 2% building the cloud and 98% operating the cloud. And so having all of that built in, to your point on failure domains, we've had drive failures, we've had power failures, that eliminated an entire failure domain. And so it's absolutely critical that we can just, I'm going to say, power through that, because we don't have to think about it. It's solved for us. So that's, really a core capability that has enabled us to focus on the performance aspects, et cetera, that our customers want and operate a highly reliable, highly available cloud platform.
Okay, so this one is for Mike, and it's what kind of networking, like connectivity between instances, do you offer?
Yeah. I definitely, it's great that folks bring up networking because yes, you have these amazing GPUs, you have disks. How do you get data anywhere? How do you get data from the outside world, and the public internet onto an instance in order to be able to feed it? So we've invested pretty heavily in networking. One, running very large dedicated fiber lines to our data centers, terminating them, getting into our VPC, which is 200 gig Ethernet today. So we're sort of trying to push the bounds of what you can get single server performance wise. And we've, at some point in the future, I'm sure we'll talk about how we built our VPC network and sort of a bunch of the tools, some open source, some proprietary, that get that to a point of very high performance. The other side of that is the InfiniBand networking. So for folks that are doing GPU to GPU, how do you actually have that data transfer go over a second network that is even more performant? And at some point, I'm sure maybe we can have a discussion on things like GPU direct RDMA. Maybe that's like a whole other hour-long webinar. But how do you get data back to a GPU even faster? There are some other really interesting networking things that you can do there. So great question.
Okay, great. This question is for Abel, and it's about how does Lightbits handle failures?
Yeah. So we partially covered that in the previous question. And basically, Lightbits protects data from SSD failures with the erasure coding elastic RAID, and it protects data from server failures via synchronous replication. So even in the case of failure, the latest bit and byte that was written by the application is always persistent and available to the application. Self-healing, as I mentioned before, it's critical. You don't want someone that needs to get involved in the data center to fix the failures. So we also have a self-healing capability, not just at the SSD level, as I mentioned before, but also at the server level. If a server fails, we will detect that and we will create all the replicas of the data that this server was responsible for across the remaining healthy servers. We look at the performance utilization, the capacity utilization to balance and take care that the cluster is always healthy, up and running.
Okay, great. There's another question that sounds like it might be related to it. Can you do a rolling upgrade without downtime?
Yes, and this is actually a critical feature for software-defined storage because you do expect to get more features, more improvements after you deploy the system. And you don't want to get into the point that you need to schedule a maintenance windows. Maintenance windows, and Mike can probably comment more than I can, in the cloud are painful. You don't want to get to the point that you call the customer, hey, your system will be down between 12 a.m. and 7 a.m. the last day of this month. You don't want to get there. So rolling upgrades are critical. We basically have our internal mechanism to deploy the upgrade of the software in a way that does not disrupt the application. The applications continue running, have access to the data, can read, write, while we upgrade all the software in all the servers in the same cluster, one by one, while still monitoring and keeping that the data is protected and not compromising any service availability.
Yeah,
Great.
I was just going to chime in and say we have done upgrades and we have not had a maintenance window. So, it is demonstrable and it is critical to our customers. We've run OS disks continuously for a year at this point and had no issues from hey, we have to bring a server down for maintenance to tell customers that.
And that spares you going in on the weekend, I'm sure, too.
I'm doing that as well, but different set of problems.
Okay, it's not us. Great. Okay, so Alexi, I don't want to leave you out here. What is your perspective on the GPU shortage? It was well reported in August that it's going to last a year and a half. Do you see it that way, or do you think it's going to let up anytime soon?
Yeah, it's a very interesting market right now, and so there's a lot of demand. A lot of new GPUs are coming into play. So traditionally, NVIDIA has been the big player. AMD's coming out with their MI300. I believe Crusoe is going to have instances of that as well. So we're starting to see pockets of availability. I do think there's other considerations such as the power grid, right? So these systems do consume a lot of power, and so there's going to be power requirements. How do you cool it? So I do think that's going to come into play with availability, as well as networking. So the high bandwidth networking, there's a lot of demand, probably even more demand than the GPUs themselves. So the systems are slightly easier to get than some of the networking. So really understanding the whole picture is really important. And so if we're talking 10 systems, that might be easy. 4,000 systems, that might be a little bit harder, and you need to plan for that a little bit more. Yeah. Overall, I do think that the market is becoming a slightly lighter than it was before, but it's still in high demand.
Yeah. Yeah, and I'm glad you brought up the power again, because that's one of Crusoe's great advantages. I was so excited, Mike, when I saw Crusoe was on 60 Minutes talking about how in Wyoming was doing all this recapturing of the energy that's normally wasted. And I know you have work in spots in Iceland, and I don't even know where else, but being able to make sure we make the most of our energy is important for all of us.
Very much so.
Okay, so let's see. When this one came in, this one's for Mike. Does Crusoe provide optimized GPU storage recommendations based on different AI workloads to increase the efficiency of your resources?
Yeah, that's actually a really good point. The resource utilization, right, is actually the most critical piece in a GPU workload, keeping the GPUs fed, which is why we care so much about high performance storage. Right? You don't want a $25,000 H100 sitting doing nothing because you can't feed it, right? All for want of a bigger pipe. So that's part of it, and that's why we've cared so much about optimizing storage. But the other piece now is starting to think about fleet-wide utilization. We're actually starting to work on managed Kubernetes and managed Slurm, so the sort of orchestration frameworks around compute to help provide that, right? To pipe out all of the metrics and say, hey, you are at M% cluster utilization. That allows us to build an autoscaler, right? And we could horizontally autoscale for, right sizing an inference workload, for instance. Or we could vertically autoscale on a single machine of, hey, you're at 95% GPU VRAM utilization, bump up the next size, and be able to get a larger machine. So the short answer is, not today built into the product. We obviously have a solutions engineering and sales team that's happy to provide those. We have a bunch of benchmarks that we're happy to provide as well. Obviously, hopefully the storage benchmarks prove that we know how to benchmark things. We do the same thing for benchmarking various different types of machine learning models. So my quick pitch, we don't have a fancy QR code, but if you go to crusoe.ai/cloud, or you can email sales@crusoecloud.com, we're happy to chat about that. Does that answer the question?
Yeah, I think so. So, this question is probably inevitable, and there are two variations of it, but it's comparing Crusoe Cloud to AWS, Azure, and GCP. So first question is, is your pricing structure similar? Like, do you offer reservation pricing? And then just more generally, how do you differentiate?
Yeah, a great set of questions as well. So the cloud is fantastic in that, at its core, the cloud is other people's computers, and we've built good business models around, renting computers from the internet. So we do offer both on-demand instances as well as long-term committed reservations. So you can do, again, that bill by the second model, right? So if you use a GPU for 37 seconds, we will only bill you for those 37 seconds or whatever it ends up being. A lot of hyperscalers would end up, historically billing you by the hour, right? So you'd end up rounding up. And again, like we want to be very clear of you're paying for what you're using, right? That consumption model holds. Obviously, if you know that you're going to have 1,000 GPUs for 18 months on a training workload, we do long-term reservations there, and again exchange the sort of significantly lower costs relative to hyperscalers for that sort of long tenor. We are exploring, the sort of missing category here, things like spot instances, and potentially even, AWS, I think has recently done the sort of concept of like buy a big fixed block, sort of on spot, so you can run a training workload for 2 weeks. So we're actively exploring those and happy to work with customers to ensure, again, high utilization at the right price, that price performance piece. In terms of differentiation more broadly, a lot of it comes down to we are an AI-focused cloud. We're not building 80 million different services. We are building the services that AI and ML practitioners need to succeed and will make their lives easier, right? The tools are very focused on, you want to run a cluster of 1,000 GPUs. You want to run inference workloads, right? We have a bunch of all of our curated images have all of the ML tooling baked in. So you can just spin up an instance and run your model. That is a huge portion of the differentiation. I think the environmental story is a huge differentiator as well, right? We are working on providing, at worst, carbon neutrality, and at best, we have some really interesting technology that is actually carbon reducing, right? It is lowering the net emissions of the world. A lot of hyperscalers are working towards zero. We're working, at a negative number. We're actually really pushing the horizon there.
Great.
So, yeah, thank you.
Thank you. This is for Alexi. Are you finding that more cloud service providers like Crusoe are building AI clouds or adding to the services they offer AI?
So building more services into their AI?
Or even offering an AI service is the way I read it. Like they don't do that now.
Yeah, so we are finding, so AI, there's a lot happening in AI. So and I think part of the market is trying to define where and what is happening. So right now it's kind of everyone's just developing for AI workloads. But at a certain point, efficiency is going to come into play in those workloads, and so model optimizations and tweaks. So we do see different cloud providers offering different types of services. So some who are focusing on developing models, really, they might offer services around optimizations of the specific models. So some are providing just kind of the hardware. So really it depends on the structure of that provider to what services they are offering.
Thank you. So this one, I'm not sure who's going to be able to answer. Maybe you all will have a different perspective on it. Is storage latency performance more important for AI training or for AI inference? Who wants to grab that one?
I can take it.
Okay.
So I will say that it's important for both of them. Now, training, it depends on the model that you are training, right? One thing is like image training, for example. Another thing is an LLM training. And some of the training models typically use more like huge amount of small files. Other models are more like still a lot of files, but bigger files, but less files. So for the models that requires huge amounts of small files, latency becomes more critical because you are all the time opening different part of the data set, and you have ping pongs between the storage and the training model, and you need to keep the latency as small as possible. Inference, it's always important to have lowest latency as possible because you want to provide the answer as fast as you can. You don't want to let any person wait for you to give the expected reply.
Yeah, and I think especially as we get towards multimodal inference of, right, the feed an image and a text prompt and generate a new image, we're feeding a lot of data of different sizes. And so, we need to ensure that really predictable latency and high throughput in order to make that happen, right? Again, you don't want to be starving your GPU because you're waiting to pull the image in from memory. Well, you could otherwise be doing good work there.
Great. So this one is for you, Mike. And you mentioned a customer before, but this person wants to know, what is the most demanding application that you have today?
Yeah. From my perspective, I see a cluster of 1024 GPUs churning away for 18 months straight, training a foundational model. That seems pretty demanding computationally. I think, and those folks are really pushing the boundaries on, let's build a giant, giant meaning tens of billions or hundreds of billions of parameter LLMs that folks will then fine tune. Or people are starting, again, I'm really on a multimodal push, because again, I think that is where a lot of the industry is going, right? Read in your PDF, watch that all hands and summarize it, and then generate an email to send to the company, right? All of these different axes, we need to be able to pull all of those pieces of data in. And so those are a lot of the workloads that we're seeing that I think are pushing the hardware and the software to its limits. From just like a technically cool, I think a lot of the scientific computing workloads are just really interesting in my mind, and they're tackling really hard problems, right? Like, predicting the weather is basically build a entire simulation of physics for the world, right? Like, that is an insane problem to start tackling. And it's really, really interesting to see how people are applying sort of traditional scientific principles with artificial intelligence to try and make those problems tractable. So again, particle physics simulation, weather modeling, et cetera. In my mind, those are the cool ones that are really pushing the boundaries.
Great. We're starting to close up here. Maybe this will be our last question. For Lightbits, how will you utilize it beyond the primary storage for your AI cloud?
We discussed about this at the beginning of the webinar, that storage is the key part for any AI cloud and for AI in general. AI is all around managing the data, reading the data, providing all the speed that fits. So block storage is the underlying common infrastructure that any other type of storage needs. Whether you are using shared file system, local file system, object store, you need block storage. And you can use block storage directly. As Mike was mentioning also before, you can run your own compute instances with storage and build your own file system, your own object store on top of that.
That's actually a great point, and I can't believe that we've gone almost a full hour without someone saying it is a fundamental building block of the cloud. That we've missed that pun for the entire webinar. But Abel is completely correct, right? We have those very high performance storage CPU instances that have local NVMe, and that is then backed for scale out with Lightbits, right? So if you want to build a petabyte scale file system on Crusoe today, you can do that with a couple of these instances. And most of that petabyte is being served through Lightbits. So really, I think there are a lot of great opportunities from those fundamental primitives of block storage devices that have the predictable latency performance and very economical cost. The sky is the limit from there.
Great. Well, we're at the top of the hour. I want to thank everyone. First of all, I want to thank our presenters, Mike, Alexi, and Abel, for sharing their insights. And I want to thank all of you who joined us today and asked a really long list of questions. Thank you so much.